Hello again, everybody. We are here still in section 4.6 for a second example. In this problem, we are going to use Newton's method to approximate the fourth root of 2 to 4 decimal places. Okay, so this problem's a little different from the one we did before because the problem we did before, example 1, we were given the equation and we were told to find the root of that equation. Now we're just trying to approximate the value of this number right here. Okay, but what we're going to do is we're going to work this backwards a little bit so that it actually ends up looking more like the previous example. So we're going to take this value and we're going to work backwards to find the equation that this would be a root of. Okay, so let's see what I mean there. All right, so the big question is, what equation is the fourth root of 2 a root, and not like fourth root, this is meaning like a 0. What equation is that a 0 of? Okay, that's probably not the best English. Don't show that to your English teachers. But we want to find an equation that works for this. So we want to find an f of x that equals 0 when x equals the fourth root of 2. Okay, so that is actually right where we're going to start, the fact that we want x to equal the fourth root of 2 here. So we're going to write that down, x equals the fourth root of 2, and we're going to work this backwards, okay, to make it into an equation that equals 0. So we're going to take that fourth root of 2, and let's raise both sides of this to the fourth power so that we would see, okay, if x is going to equal the fourth root of 2, then x to the fourth has got to equal 2, okay? And then we want this equation to equal 0, so just subtract the 2 on both sides, and we get x to the fourth minus 2 equals 0. Okay, so we actually just found our function. This, x to the fourth minus 2, is going to be the f of x that we want to use, because that's going to cause f of x to equal 0 when x equals the fourth root of 2. Boom. All right, so that is the function we're going to use. Okay, take that over here. F of x equals x to the fourth minus 2. Okay, so let's see, let's set up our Newton's method equation. So we're going to want Newton's method. Want that formula here. Okay, x sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n. Okay, and then we'll make the more custom fit for this problem that we're looking at. All right, there's our f of x. We'll need its derivative as well. That would be 4x cubed. All right, so our Newton's method formula is going to look like this. X n plus 1 equals x n minus x n to the fourth minus 2, that's our f of x n, over 4x n cubed. Okay, so that's what we're going to be typing into the calculator a little bit later. All right, now we need to find an x sub 0 or x naught value. So let's think about this. All right, so the fourth root of 2, well, we know we want x to the fourth to equal 2. So let's kind of think about ballpark where that's going to be. And don't just type it in on your calculator quite yet. We'll use that to check at the end, but we're going to do this from scratch here. So what should our starting value be? What should x naught be? All right, so let's think about some values here. We want x to equal the fourth root of 2, okay? We want x to the fourth to equal 2, all right, that's true. So let's think about some x values here. Like x equals 1 would be less than the fourth root of 2. All right, because 1 to the fourth would equal 1, and that is less than 2. Okay, so that could be kind of a boundary on one side here. X equals 1 is going to be too small. Well, smaller than the value that we're looking for. Okay. And then let's try on the other side of that. If we went to x equals 2, that is actually going to be on the larger side. This is greater than our value. So x equals 2 is greater than the fourth root of 2. Okay. Because if we took 2 to the fourth power, that would be 16. And so that way overshoots a value to the fourth being 2. Okay, that's way larger. So it looks like from this, the fourth root of 2 is going to be somewhere between 1 and 2. And really, if you think about it, it's going to be quite a bit closer to x equals 1, because 1 to the fourth, 1 is a lot closer to 2 than 16 is. Okay, so 16 is significantly greater than 2. 1 is a little bit less than 2. So the fourth root of 2 will be between 1 and 2, but closer to 1. Okay. So that actually gives us a pretty reasonable ballpark of where our value's expected to be, somewhere between 1 and 2, but closer to 1. And that tips us off to what we should probably use for our x naught value. Let's go with x naught equals 1, because we know our value for our actual root that we're looking for is close to that, okay? And that's what you want with that x naught. All right, so we're going to use this formula right here, and we're going to use now x naught equals 1. Because of this. And so let's put it in. All right. So x naught equals 1. Then x1 would equal x naught minus x naught to the fourth minus 2 over 4 x naught cubed. Okay. And so that would be 1 minus 1 to the fourth minus 2 over 4 times 1 cubed. This one is actually nice enough that we can do it by hand for the first iteration here. This is going to be 1 minus, okay, up in the numerator, that would be -1, and denominator would be 4. So it's going to be 1 1/4. 1 1/4, or 1.25 if you rather. So, hey, we got an exact answer there, for x1 at least. Now, when we go and find x2, probably a little bit of a different story. Okay, so x2 is going to be x1 minus x1 to the fourth minus 2 over 4 x1 cubed. And if you really felt like it, you could work this one through by hand if you really wanted to, but let's use our calculator here. Newton's method is nicely designed for calculators. Let's take advantage of that. Okay, so let's go over to our calculator here. And how many decimal places are we going to? We are going to 4 decimal places here. Okay, so let's make sure we keep that in mind. All right. So let's go run our formula. All right, and remember how we started this process out last example was just by entering your x naught value. So here's x naught, it's 1. We've got that stored as our answer now. Okay, so now is when we take advantage of that ANS answer key. Okay, and we're going to put in this formula effectively, but where it says X sub n, we're going to use the ANS button. Okay, so we use answer button to type that in. All right, so that would be X sub n, which is our answer, minus f of x, so that's the numerator. Let me put some parentheses around that. Be careful with your parentheses. Okay, so that was xn to the 4th, and then minus 2. Okay, so there's our numerator. And then for the denominator, it's 4 times xn, so your answer cubed. Okay. And so we hit enter, and look, we got 1.25. So this matches up with what we did by hand. That's a good sign. All right, so that's x sub 1. We had found that. And so now remember, to find x sub 2, here's where things get nice and easy with the calculator. You get to press second and enter to get that exact same entry back. And now answer, ANS, is 1.25 instead. So we just press enter, and there is x2, 1.1935. All right, so let's write that one down. 1.1935. Okay, and then for x3, we would go in and do this again. Now our x2, that 1.1935, is going to be the ANS key, okay? And we're going to use the exact same formula with it. Okay. So we get to just repeat that process, use the same entry, and just press enter. All right, looks like we got 1.1892. 92302. All right, so I'll write 1.1892, and then just kind of for our little reference, 1.1892302. Okay. And then for x4, you don't even need to keep writing that formula at this stage. We know what we're using. So we'll just do this one directly in the calculator based on our x sub 3 that we just got. Okay, we do the same entry and press enter. Okay, and we get 1.1892 again out to 4 decimal places. Okay, 1.1892071. Let's go write that down. But yeah, we get that 1.1892. Okay, 1.1892071. All right, so the fact that out to 4 decimal places, which is as precise as we were told to be with this problem, out to 4 decimal places, these two answers match. So that means that our Newton's method here has converged at least to 4 decimal places. Okay. Now, if we look out a little further than that, to 5 decimal places, it would not be considered to have converged yet. Okay, because this one has 3 in the 5th decimal place spot. This one has a 0. Those don't match, so that's not converged. All right, but out to 4 decimal places, we got it. We got convergence, and so we would say that this is our approximation for the 4th root of 2. Okay. Just for a little curiosity here, if you go a little further, if you do x sub 5, let's see if it converges to another decimal place there. All right, just for fun. Yeah, it did converge to another couple of decimal places. So see, that is all good through 8 decimal places there. We have convergence after just getting to x sub 5. So Newton's method is pretty effective for a lot of problems. All right, you can get convergence pretty nicely here. Okay, I'll erase that little x sub 5. That was just for fun there. Okay, so yeah, we have our convergence to 4 decimal places. So for our answer here, we would say that the 4th root of 2 is approximately equal to 1.1892. Okay, and that's our answer. Now, if you're curious, let's take a look at the actual 4th root of 2, just typing that in on a calculator. Type in 4th root of 2, and let's see what we get. Okay, so the 4th root is over in this math menu. Okay, that button right there. You're going to use the 5th selection there where it says x root, but we're going to need to type in a 4 first because we want to take the 4th root. Okay, so get out of that menu and type your 4 and then go use that 5th root there. Okay, so the 4th root of 2. Enter. Wow, look at that. Okay, so the 4th root of 2 is definitely about 1.1892. We have totally hit that to 4 decimal places. And look, out to the 9th decimal place there, as many as the calculator is showing us on screen. This exactly matches that was the x sub 5 approximation right above it. So x5 matches up with, as far as we can see, everything that the calculator is giving us for the 4th root of 2. That's pretty awesome. So yeah, that is the power of Newton's method. I'll go back and write our 4th root of 2 on the notes here. 1.189207115. All right. Matches with our x5 approximation. Nice. Pretty neat. Okay. So yeah, that is Newton's method. Cool.